Hello everyone, my name is Tarana Vidya and today I'll be presenting on Zero Trust Security Architecture, a modern approach to cybersecurity often summarized by the phrase never trust, always verify. So over the next few minutes, I'll explain why the traditional perimeter-based model is no longer sufficient, what the core principles of Zero Trust are, the components and the technologies that makes it possible, and how organizations implement it step by step. Then we'll see the real-world examples, the benefits and challenges, and where Zero Trust is heading towards in the future. Then I'll conclude with the practical takeaways you can apply or suggest in a workplace. So let us start with a quick story to set the context. For many years, organizations built securities like a medieval castle. Strong perimeter defenses like firewalls and VPNs, and once someone was inside the wall, they were mostly trusted. That model worked when most of the employees and servers were inside a physical office and traffic stayed on the private networks. But today's environment is quite different. Employees work remotely, cloud services host critical data, contractors and third party vendors need access, and devices are personal and mobile. So attackers have the sophisticated tools and social engineering techniques. So a single successful attack can lead to a broad internal access. So zero trust was developed specifically to address this reality, rather than trusting anything based on network location. Zero trust assumes compromise is possible and requires verification for every access request. In short, it flips the security model onto its head. So the core concept is very simple, but it is very powerful. No implicit trust. Every request, whether from a user, a device, or a workload, must be authenticated, authorized, and continuously validated. The emphasis moves from protecting a single parameter to protecting each resource individually. This is accomplished by treating identity and device posture as primary controls. For example, instead of allowing all internal users to browse an internal database once they are on the office LAN, Zero Trust might require each user to re-authenticate, check that the device has up-to-date patches, confirm that the user role permits the access, and only then grant a short-lived session token. If any of those signals change during the session, access can be revoked immediately. So this approach reduces the attack blast radius and makes the lateral movement difficult, the typical path that attackers take after an initial breach. So, zero trust rests on the three main principles. First, verify explicitly. Do not rely on a single factor. Use multiple signals such as identity, device health, geolocation, time of the day, and behavioral analytics to assess the risk. Second, least privilege access. Users and services receive only the permission when they absolutely need, which reduces the damage in the case the credentials are stolen. Implementing least privilege also means granting access with the minimum time necessary, using just-in-time privilege elevation when required. Third, assume which. The systems are designed in such a way as if the attackers are inside. That assumption drives segmentation, strict logging, and rapid detection and response. So, when you combine all these principles, you can create an environment where compromise is much likely to turn into a major data breach. So, now let us compare the two models side by side, that is the traditional and the zero trust model. So in the traditional model, there is a perimeter. So firewalls and VPNs are relied upon heavily. Once inside, users are trusted and often have broad access. This model can be efficient, but it is very brittle. So if an attacker breaches the perimeter, then they can move laterally. In zero trust, there is no implicit internal trust. Access decisions are identity and context based, and verification is continuous. Rather than a single perimeter, zero trust enforces many micro-perimeter closer to the resources. This reduces the attack surfaces and gives administrators much greater control over who can access what. In practice, this means more upfront design and tooling, but a much stronger security posture against the modern threats. So now let us see the key components of the Zero Trust architecture. To operationalize Zero Trust, you need several components working together. The first one is Identity and Access Management, or IAM, is foundational. This includes strong authentication mechanisms like multi-factor authentication, that is MFA, single sign-on, SSO, and fine-grained policy engines, RBAC or ABAC. Then we have device security. Device security ensures the device posture is healthy. That is, it checks the OS updates, endpoint protection, disk encryption, and compliance checks. Then we have the network segmentation or micro segmentation, which isolates the workloads and reduces the lateral movement. And then We have the continuous monitoring and telemetry, which is SIEM or EDR, provides visibility and detection capability. And importantly, we have the data protection. This takes care of the encryption, DLP policies, and classification. This ensures the data remains protected even when accessed. These components must be integrated so the identity, device posture, and telemetry informed access decisions are in real time. So now let us see the implementation steps. Implementing Zero Trust is best done as a program rather than one-off project. Here, there is a practical five-step approach. The step one is to identify your surface. So here we list the critical data, applications, assets, and services, which is nothing but DAAS. That is, if they are compromised, they cause the most harm. Step two, we have map transaction flows. Here, we document how users and systems can interact with the Protect services so you know where to place which controls. Step 3 is build microparameters. Here we apply segmentation around each Protect surface and create policy enforcement policies. Step 4 is to implement the policy intents. Here we implement the policies that should be risk aware and derived from the identity, device posture, and context like time or location. Then we have the step 5 where we do continuous monitoring and improvement. We log everything, analyze for the anomalies, and iterate. So a helpful tip would be we have to start from a very small one, pick one critical application or services, and then we have to implement the zero trust controls there, and then we have to measure the improvements, and then we have to scale up. So now let us see the technologies enabling the zero trust. Several technologies make zero trust feasible and effective. MFA or the multi-factor authentication is non-negotiable. It raises the bar for the attackers. SSO also reduces, that is the single sign-on, reduces password fatigue while enabling centralized policy. Then we have the next generation firewalls and the micro-segmentation tools which enforce granular network policies and workload. Cloud Access Service Brokers or CASB gives visibility and controls for the SaaS applications. Then we have the EDR tools or endpoint detection and response tools, which continuously monitor the endpoints for suspicious behavior, and SIEM that is the SIEM platforms, collect logs to detect anomalies and support the investigation. Finally, the artificial intelligence and the machine learning helps by analyzing large volumes of telemetry data to find subtle deviations from the normal behavior. So together, these technologies create an ecosystem where access decisions are data driven and enforced in real time. So now we have zero trust in the cloud and the hybrid environment. Cloud and hybrid environment are a major reason zero trust matters. In cloud, first organizations, applications, and data moves on between the on-premises and the public clouds. So a static perimeter does not protect them. So zero trust shifts security to an identity and resource-centric model, applying the consistent policies regardless of the physical location. So, for example, rather than relying on the corporate land to make the trust decisions, Zero Trust uses identity providers like IDPs and policy engines to grant to applications hosted on AWS, Azure, or private data centers. So many cloud providers often identity-aware proxies, conditional access, and workload segmentation features that align with the zero trust. For hybrid environment, the challenge is to maintain consistent controls across the different platforms, which is why orchestron and centralized policy managements are very critical. So now let us see the benefits of the zero trust. Zero trust provides several compelling benefits. First, it reduces the risk of large-scale breaches by limiting the attacker's movement through segmentation and least privilege access. Second, it improves the visibilities. You can see who accessed what and why they have accessed it, which aids investigation and compliance. Third, it supports remote and hybrid work. Because security decisions are bound to identity and device checks rather than network location. Fourth, it simplifies compliance, reporting by producing logs and enforcing data access policies consistently. Finally, by enforcing access on a per person basis, it reduces the attack surface. Fewer broader access credentials exist, making successful attackers harder and less damaging. So now let us see the challenges in the implementation. So despite the benefits, zero trust has real challenges. Legacy systems often lack the telemetry or authentication hooks needed for fine-grained policies requiring significant refactoring. The initial investment in tools, architecture design, and skilled staff can be substantial. It is very costly actually. There is a there is also an operational complexity. Continuous monitoring produces a lot of data, and without good automation, it can result in an alert fatigue. Organizational culture must shift. Developers, IT ops, and security teams must collaborate very closely. Lastly, user experience is a concern. Poorly implemented policies can create a friction, so it's important to design policies that balance security and the usability, such as using adaptive authentication that steps up only when the risk is detected. So now let us see the real world examples. Zero trust is not just theoretical. Several high profile organizations have deployed it. Google's Beyond Corp is a well known internal implementation that removes the traditional VPN instead relies on the device inventory, health checks, and user identity to grant the access. Then we have the Microsoft, which provides a zero trust framework integrated into the Azure Active Directory and Microsoft 365, offering a conditional access based on the signals like device compliance and the location. And then we have the government and the defense organizations are also adapting the zero trust to protect the critical infrastructure. These examples show zero trust scales across different types of organizations, and the large complex environments can transit successfully if they plan carefully and prioritize the most critical assets first. So now let us see the future of the zero trust. Looking ahead, zero trust will evolve with technology trends. Artificial intelligence and machine learning will enable more adaptive policies that can change in real time based on the user behavior and the risk profiles, reducing the false positives. Behavioral biometrics and continuous authentication may make verification less intrusive, verifying users based on their interactions rather than repeatedly asking for the credentials. Zero Trust will also expand into IoT and edge environments where billions of devices will need a positive like posture validation and segmentation. Additionally, Zero Trust as a service, that is ZTAAS, will become more common, letting smaller organizations adopt Zero Trust without large in-house teams. Overall, Zero Trust will increasingly be default security posture and the cloud first and the hybrid organizations, which are the future and currently also used. So now let us summarize the whole concept. The zero trust is a shift in the mindset more than a single product. Its core motto is never trust. Always we have to verify. So captures the need for the continuous authentication and authorization for every access request. The key components include a strong IAM, device posture checks, and then we have the micro segmentation, continuous monitoring, and data protection. So the implementation here is iterative. We have to identify the most critical assets, map flows, and build perimeters, and for enforce policies, and continuously we have to monitor them. So while there are challenges, particularly with the legacy systems and the cultural change, this is security improvements, especially in the cloud and the remote first environments and the hybrid environments, are very compelling, and they require zero trust architecture. So these are the references which I used for the presentation. And yes, that brings to the end of my presentation. Thank you for listening. The key message I want to leave you with this is never trust. We have to always verify. This is a core idea behind the zero trust security. Thank you once again.